Hello, this is question 1 on January 2022 paper. It's an statistics 2 question and it's mainly about approximations, although you have some Poisson and some normal distribution. And I'm going to show you how you can get full marks with this question. So you have local pottery makes cups, and the number of faulty cups made by the pottery in a week is a Poisson distribution with mean of 6. In a randomly chosen week, the probability that there will be at least X faulty cups is this value, and we have to find X. So first of all, we have to define our variable. I'm going to call it X. It doesn't matter how you call it. This is the number of faulty cups in a week. Remember, every time you define a Poisson distribution, you have to mention the period of time that is happening. So 20 minutes, or in a page, in case of words, or something like that. So you have to give an interval. This is a Poisson 6. And they ask me what is the value of X, such as the probability of being at least X is going to be this number here. In the Poisson distribution, in the tables or in the calculator, I don't have the greater, I have the smaller or equal, so I have to write this as 1 minus probability of X being smaller or equal than X minus 1, so 1 less, is going to be 0.1528. Here, you are getting 1 mark for the method. Then, this is going to be the same, that the probability of X being smaller or equal than X minus 1 being 0.8472. So I'm just taking away 1 minus 0.1528. And then we can go to the table, to the Poisson 6, and search for this value. So I'm going to show you the table. This is the formula booklet that you have, Poisson distribution, 6. So I'm going to use this column, and I'm going to find this 0.8472, which is here, and the X is 8. But this is not our 8. This is really this value here, so X minus 1. Therefore, X is going to be 9. So you have 1 mark here for using this method, and another mark for the final answer. So this is your first 3 marks, and this is A. Sorry, I didn't write A. Then the second part, they say use a normal approximation to find the probability that in 6 randomly selected chosen weeks the total number of faulty cups made is fewer than 32. So we have first faulty cups per week. Now we have faulty cups per 6 weeks. So that means we have a new variable, and I'm going to call it, I don't know, X prime, for example, that is faulty cups in 6 weeks. So if in a week I have 6 faulty cups, in 6 weeks I will have 36. So this is a Poisson 36. And they are asking me to find probability the total number of cups made is fewer than 32. So I need to find the probability that this new variable, X prime, is less than 32, where this is a Poisson. But they ask me to approximate that with a normal. So I'm going to approximate that with a normal, and my normal, I'm going to call it Y, is going to be normal. Remember the approximation, when I'm approximating a Poisson by a normal distribution, my mean is the parameter and my variance is the parameter as well. So my normal is 36, 36. This is already 1 mark, just for using the right approximation. They tell you that it must be a normal, but you need to remember well the parameters. So this is my Y here. This Y is a normal distribution. Probability of Y being smaller than, and remember, when I change from a discrete distribution like Poisson to a continuous normal distribution, I have to apply the continuity correction. So if it must be smaller than 32, that means that it's going to be smaller than 31.5. So I'm going to translate this into standard normal distribution. So now I'm going to have probability of Z being smaller than 31.5. So I'm just doing change of variable here to have a normal 0, 1, a standard normal distribution. So now we will have a normal 0, 1 that allows me to use the tables. This is minus the mean, which is 36, divided by the standard deviation, which is root of 36, which is 6. So this is the probability of Z being smaller than minus 0.75. And I have 2 marks here for the method. So I have 1 mark for the correction and using the correct number here, and another mark for standardizing or making your normal distribution a standard normal distribution. So remember, when you have a normal distribution, in this case we have our normal 0, 1, this value here is 0, and I need to find the probability of being smaller than 0.75, but this is not going to be in the table. I need to find the positive one. This value is 0.75, but again this area is not on the table. What I'm going to find on the table is the area on the left of the 0.75, so this area here. That way this probability is going to be is the pink one, and the pink one is 1 minus the blue one, and the blue one is the probability of Z being smaller than 0.75, and I have this value on the table. So if you go to the normal distribution table, I have it here, so it's S1 here. You find the 0.75 for Z is 0.75 is here, so that probability is 0.7734. So this is going to be 1 minus 0.7734, which is 0.2266. And that's my 4th mark in this section. So that's the probability that I was looking for. And for C, they say a week is called poor week if at least X faulty caps are made, where X is the value found in part A, so this value X. Find the probability that in 50 randomly chosen weeks, more than one is poor week. We have 50 weeks, we have a probability of success, and we are finding a probability, so this sounds like a binomial. So let's say that W is number of poor weeks, in 50. So that would be a binomial. We are checking 50 weeks, and the probability of being a poor week is the probability of at least X faulty caps, which is this value here that we already have. So 0.15 to 8. This is my binomial, and we need to know the probability of having at least one poor week out of the 50 that I'm checking. We know this is not on the binomial calculator or the tables. We know this with a smaller or equal. So this is 1 minus probability of W being smaller or equal than 1, because I don't want to include the 1. Smaller or equal than 1, this value of probability is not on the binomial table. So if you see the binomial tables, I have them here, we don't have that probability, right? So we need to use the tables. You could use the calculator, but you should use the, no, not the table, the formula. So this is 1 minus the probability of being 0 or W, 0 or 1. So we are going to do them both, and the binomial probability distribution, the formula is this one here. So you have it in the formula booklet. So we are going to do n over x, px, 1 minus p, n minus x. So let me show you. So it's 1 minus, the first one is going to be 50 over 0, because x is 0, p to the power of x, p is 0.1528 to the power of 0, and then 1 minus that, which is 0.8472 to the power of 50, plus, now I'm doing the second probability, so 50 over 1, 0.1528 to the power of 1 times 0.847 to the power of 49. So I'm just using the binomial formula. And if you do that with the calculator, it's going to be 0.99748 or 74 if you want to round. And this is 4 marks. So the first mark is 4 marks, right? So we have 1 mark. Let me do it. 1 mark for saying that this is a binomial. So the first mark is for finding that's a binomial. Second mark is for the method. So here, for saying that one probability of greater than 1 is 1 minus the probability of smaller than. Then the other mark is for this whole method, for using the formula and substituting correctly. And the last mark is for the final answer. So 1, 2, 3, 4 marks. Yeah, so this is, and this is C. This is a question where you mix a few things. So you mix approximation, you work with Poisson, normal distribution, and with binomial. And that's all for this question. Hello! If you like the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website and the link is as well in the description below. I would love to help you.